Hi everyone, it's Stolz from a garage in Khabarovsk. In this video you'll see a review of a new Denzel D7500 electrical motor. And also, I will show you a relatively new Chinese type of motors, IPMSM, with built-in rotor magnets. It's an experimental sample. It has a large space for Hall sensors here. In a serial production, this space will be thinner. But I have this one for now. The way of rotation is the first sign that there is no magnetic sticking. Now let's weigh it. 8.22 kilograms. Remembering the typical Chinese motor's proportions, with 4 kilograms per 1 kilowatt of motor power rating. This 8-kilogram motor has 2 kilowatts of motor power rating in S1 mode. Earlier, there were other Chinese motors with similar characteristics in the market, like this Quanchun with 138 motors. It's a well-known fact how good they are, partly because of the characteristics I've just mentioned. So, finally they started to produce new motors, IPMSM as well, but there's some more that differs these kind of motors from others. And this is not only built-in rotor magnets. And now I'm going to take it to pieces. So what we can see inside is pretty unusual. Here is a machine winding with rectangular section wire. There are 6 huge magnets placed deep inside of the rotor and lots of little teeth of the stator. The winding with rectangular cable cords gives one advantage, which would be unreachable with thin winding. It's a perfect filling of stator groove with copper. On the other side, we can see manual TIG welded current leads. I'd like to draw your attention to a microscopic air gap with the size of 0.2 mm between the stator and the rotor. The smaller the gap, the better. Thanks to the inner placing of the magnets, it's not needed anymore to take into account the rotor's outer surface curving and make a gap as small as possible. The length of the rotor with magnets is 76 mm. The diameter is 81 mm. Hall sensors are made by SMD technology. They are placed on a rotational disc for additional tuning if needed. The false rotor consists of an aluminum ring with 6 ferritic magnets in it. There are 3 screw clamps of phase conductors on the outer side of the motor. And this is a breather through which we can pass the second thermosensor. Now we're going to measure the torque. This legendary stand was at the basement and now it's here. The lever's length is 20 centimeters from the center of the screw that holds the wire to the center of the motor's axis. So let's do it. I'm turning on the wire first and the motor slightly starts working. Phase current of 500 amperes. Once again.
Ну и третий раз для верности.
And the third time to be sure. .3 kilogram force with 20 centimeter lever. So if we divide it by 5, we get 5.66 kilogram force with 1 meter lever. And now let's multiply by 9.8, and we get 55 Newton meters. This is what the torque is on the phase current of 500 amperes. Now I'm going to rotate it a little. The voltage is about 100 volts. Thanks to the built-in rotor magnets, the motor works very quietly. The motor is well balanced. There is a vibration, but it's very light. The consumption of the idle capacity is 400 watts with 100 volts. It's a very good result. The motor is a bit heated with no load. This temperature is within normal parameters. Also, we can measure kV parameter. It's a turning number per volt. There are 11 teeth on the front sprocket and 32 teeth on the rear one. There's a bicycle computer sensor and a magnet here. And this is the computer. The parameter on the display is 1 meter wheel circle.
Настроен на 1 метр длины окружности колеса. Напряжение.
The voltage is 51.5 volts. And now let's have a look at some numbers. This is my T, and these are our numbers. So with 51.5 volts, the RPM speed was 6,800 revolutions per minute. The power consumption was 275 watts when we used a dry, ungreased chain. And there wasn't a wheel with a tire, what could create resistance because of the air while rotating, but still is a very good result. So the motor has a very high indicator in kV parameter, 133 revolutions per volt. But also, at the start with a 500 ampere controller, it can create 55.5 Newton meters. Because all of that, we can say that the motor has both thrust and speed. And it seems that these are incompatible parameters. Let's make some counts to understand what it means. 133 revolutions per volt and 55 Newton meters. Here we have already 1000 revolutions per minute and 117 kilometers per hour, minus 20%, and we get 93 kilometers. This is pretty much real number, and it can be reached easily. Meanwhile, we have 500 Newton meters of torque on the wheel. It's a high parameter. This leads to make a jump start. It's possible when we have 500 Newton meters right at the start. After that, parameter will be, of course, lower. Well, summing up, for the first time I have a motor that has both thrust and speed simultaneously. This one will be set on a moped in spring. That's all for now. Bye.